Hello, and welcome to another thrilling video of the ibgib prototype demo. Today we're going to just take 5 minutes to do a quick run through of how I actually use it right now. And then if you want to stick around, we'll get a little bit more technical in what's going on. But so without further ado, let's just go through the playthrough. I'll try not to pause it at all. If I do, but we'll just run through this real quick. Just quick's a relative term, I guess. So I pause it, you open it up. The splash screen doesn't get reloaded. We got the spinning fish there. It opens up to our tags. I just implemented a sketch of the paging. So now we're at our tags. I also did a little animation. There's also tags in the menu, also with our cool little robots. They're kind of like chatbots, the beginning of chatbots, but we'll get to that in another video. We go to the cheese house. That's where I live, the house I rent. Here's a little pergola slash arbor that I made. I actually ibgibbed the whole thing in Google Keep, but it has issues. Google Keep does. Also, it doesn't do a lot of things. Anyway, we go inside. I will pause it one time. We just went inside this picture, and that's the main thing, is we have pictures in pictures. Okay, we got to move away from things with decentralized, the future of decentralized data. We got to move away from siloed apps, but we also need to move away from files and folders. So right now you think of a file and you think of a folder. It was a very useful heuristic, but it's not the be all end all. So right now this picture acts as both a folder and a file, right? So we can go inside the picture. I know it's mind-blowing, but it's extremely useful, especially when we get here to the near future of Internet of Things and that sort of thing. So anyway, inside of pictures, we just clicked inside of a picture. So now our context or our folder is our picture. It's that picture of the arbor. And just switch to the wrong one. So anyway, so this is where we are. So we're inside of this picture. That we're now at a nested picture. This is the picture we're inside of. So we're going in here, and what we're going to do is we're going to update the picture. We're going to update it. Here's our old one with no growth, but right now there is growth. And I want to have time lapses of things. It's all about time. So here's what it looks like right now. We can take an updated picture. It's almost like a tag or a version control, a snapshot in time of what it looks like right now. So we just update the picture. This little modal screen here shows us what our current image is. And then once it gets done, finished encoding in base64, there we go, there's a new one. So there's the old one, there's a new one. They're about the same. It would be nice to have the overlay, like a fancy picture taker, but we don't have that. It's the native camera. So now a little picture update things going here. We could navigate away, but we're not going to on this. Watch the little picture up here, a little thumbnail, because this is the thing that's going to be updating. So it just updated, there's foliage there. We just clicked on it, and that's our updated picture, right? So not only do you have pictures in pictures, but you have updates to pictures. There's me screwing around with a little screenshot recording thing. Okay, so now the other video, which I accidentally started. This is just, 30 seconds later, but we're just going to close the app and then reopen it, and you'll get to see what it looks like going back to the same exact place. So we get our spinning whale there, little spinning car, whatever you want to call it. I am not a very good UI animations person. So here's our tags list again. We're going to go straight to the cheese house. And this is a little bit slower because it's also screen recording, taking up a lot of juice on the phone. Okay, here's our pergola. We're going to click inside of it. We're going to go inside the picture. So that's very useful for, like, instead of just having these flat folders of pictures and all over the place, you can go inside of the images, and then not only inside the images, but update timelines inside the images. So here I'm going to show you one thing real quick. I know I said I don't want to pause very much, but when it first loads right now, that's what the original picture that it was linked to. So anytime any ibgib right now is loaded up, it's going to give you what it's linked to, and then each one of these individual things, if we scroll down, this is just a video, but each one is its own timeline. So this picture we're inside of, the ibgib we're inside of, this has its own timeline. This picture has its own timeline. Any other children have their own timelines. It's all about time. It's all about distributed computation, time of multiple things, all changing independently. So here it loads up the old one. It's going to go, oh, I have a new one in my space. It's going to update. Oh, there we go. So it automatically updates to the latest thing. It's kind of like getting the head in a Git repo on whatever branch you're on. So each one of these you can think of as its own repo. Repos within repos. Okay. Keep it going here. Now we're going inside of our picture that we just updated. There's me flipping the phone around. Did the same thing up here. It updated to the new one. And there's our new picture. But then notice inside of it, it still has the same child. It still has the same contents. So because again, we don't want to think of just one picture. These are entire timelines that are implemented with blockchain type technology. I didn't do it from Bitcoin. I was already on distributed computation before Bitcoin existed. So anyway, we'll finish this up. We're going to go into a little bit of the technicals there. Here's the raw data. And then I'm just going down to show you that this binary right here is the new picture. Here's the old picture. So we didn't get rid of the old picture. We just added a new one. And then this control at the top shows the most recent in the binary relation. That's a named relation. Named links in a Merkle DAG. Okay, so this is just a little gardening example, but any picture you take, it is, you have a bunch of these pictures, you don't know where they are, they're just all over the place. It's fun sometimes to go come across them and that sort of thing. But again, this is just me programming the entire thing. So not just the app. I mean, obviously I build on top of other people's libraries, but not just the app, but the protocol itself I've been developing since before Bitcoin. I didn't know what a graph database was. I didn't know what a Merkle DAG was. I didn't know any of that stuff. But it all came down to eventually timelines, semantic timelines, kind of like Git. In fact, I've ended up reusing or re-implementing basically the hash object dictionary inside of Git, only with a different substrate. But so kind of like Git, only not doing just diffs on text. So Git is very optimized for text. They do have a a binary add-on now, but it was a second-class citizen. And anyway, the whole thing fits together with a distributed protocol. So there's our demo, pictures in pictures, timelines. If you want more technical stuff, I'll go into the same thing here, and then I'm going to open up a little bit of a live demo. So thank you for watching. Leave a comment. I don't know how to do YouTube, so we'll see how it goes. So for the rest of you, let me get it going with the coding real quick. Yeah, I wasn't prepared. Any way to pause? No. Well, I don't know how to tag them together, so. This is only one session. So with this, similar to some of the other distributed protocols, the whole point is to have mobile data. But mobile data is difficult to implement. If you have a cloud service provider for some cloud service, it's a centralized thing. There's a lot of machinery involved with getting it to be one thing. But this is about multiple timelines and having the dynamics to be able to have decentralized apps. There are other Web3 technologies out there, but this one has unique qualities, right? So, but let's look at which one is the first one. There we go. Let's look at this real quick. Come back. Right. So first, just these tags. These tags, you can have any ibgib. So a tag is an ibgib. So here's the just created tag favorite is an ibgib. It's this record. It's its own Merkle DAG. It has a past, has a temporal junction point, which is like some people think of it as a stream ID. It's the start of a timeline. But so you can add comments inside here. I only have it just displayed the same, but so here we're inside of a tag comment, right? So you can also add a picture. I usually just go over here and there's an older picture. Oh yes, it's the IncryptGib white paper. So it's a little confusing. This is just a picture of a previous prototype. So these are on the tag via this one is on there via the named pick relationship. Here is a comment. You can see the first like 10 or so characters minus special characters. That's oh, we went inside the comment. That's right. So if we, real quick, we'll add a comment here. Wait. So now if we look at the info, you can see it added another to the past, same temporal junction point, same on the pick, and the comment has, here's the nested comment on the comment relation. This is a named link. And so what I was going to say is with tags, you can tag anything. So here's our little tag. We're going to create a new tag. Test comments. Sure, call it flower. All right, so you notice it added it to our main menu on test comments. So if we go over here, now this has a link to the comment that we just tagged. So all these buttons up here, they act on the top. That's our context. I'm going to be implementing, more actions that you can do on the child items, but all these buttons up here act on the top. These buttons down here add child items. So add a comment, add a picture from the camera, add a picture or a file, and then import from space. That's the little space icon. It's kind of like from the cloud, but the cloud is not quite. I mean, it's a good paradigm, but this is a little bit different. So, and then if you notice, here's a little green indicator saying that this has something inside of it. If we just made a new one, it's not going to have a little green thingy there because there's nothing inside of it. We go inside of it, there's no items. That's very useful to know. Okay, what I was going to say is on the tags, if you look at the raw data, you can see that anything that you tag has a target. So it's just a different named relation. And then you can also have comments. It's just a different named relation. It's a different named edge. If you're in graph theory, you can think of it as an edge, or if you think of it in terms of a link, I call them relations because it's funny, like that movie. So we go back in here. So on my app, I took a picture of the pergola. We added a picture here. We go inside it. Oh, I'm just showing that tags are in the menu, but you can also again, any of these thingies, they're all the same underlying data object. So usually you have, and you can still have individual nodes with hyper optimized like databases, but databases in general have, they share a common structure of usually an append only log. And they have transactions and that sort of thing. But if you abstract away and you don't think about hyper optimizing from the very beginning, you can come up with a structure that allows for easier projections of data across spaces. So like clustering, or nowadays you think of Kubernetes pods, swarms, all that sort of thing. You can simplify it and just think of them as projections of this same underlying Merkle or cryptographic structure. So we go to the cheese house. go to the robots another day. We got our pergola. We go inside of it. So now we're inside the picture because pictures are folders, files are folders, folders are files. It's madness. No, but you can go inside of a context. And so in our case right now, our context is this. If we click on this, it's going to show us in this cheesy little modal, here's our picture. And if in case you're wondering what ibgib is, it's a hash-only encryption algorithm that I made. It's still a little, it has a couple weaknesses, but again, it's that moving away from hyper-optimizing at a low level and reusing just our one primitive of the hash functions and being able to build like even encryption models, encryption algorithms, just using that. But we'll leave ibgib for another video. But for right now, I'm just saying this picture is what we're inside of. This is our folder. If we look at the top bar, deals with the context, what we're inside of. It has a bin relation to the binary. If we were to copy that, and then, I don't know, easier just to duplicate the tab. So that binary, here I'm putting in the link to the binary, it's just an ibgib. It has its own, you know, here's the base 64 encoded binary text. It's actually a little annoying with my implementation right now because if you do this on Android or on iOS, now you're going to have what it thinks is a picture, but it looks like a broken link. It's a little annoying. I'll fix that in some future implementation. But for right now, the important thing is that it has in its ib, this is its metadata, so in its address, it has that it's a binary. This is going to be the hash of the binary itself, the hash of the base 64 data, and then it has an extension. But it's not the picture. The picture is what actually has, it just has a link to just a binary, just a raw binary. But the picture is actually what has the metadata to the thing. So you could have some other picture that links to that binary. But in this case, our picture is a different ibgib. It has a pic. The 94387 is at the, yeah, 94387. So it has the binary, the hash of the binary also. And that's all for security stuff. But anyway, here's the bin hash extension file name. This is me screwing around, clicking on it because I just did the animation from largely from the Ionic, from the Ionic animations and gesture controllers that I recently delved in a little bit more with, thanks to Simon Grimm, a very good Ionic capacitor teacher. Ionic teacher. So we're back inside it. Here's the picture. That's the old one. Notice there's no foliage. We go to the update and we can update the picture. So here we're inside of a picture. We click the little update button. Here's our picture. It's got some of that metadata that we put in there. We'll go update it with, it doesn't matter. There you go. We'll update it with Kentucky. How about that? Kentucky Wildcat, because she looks crazy. She looks wild. This is her on my my windshield one of the days coming home. Anyway, so it doesn't have to be an update to the picture. You can use it for whatever reason. The point is that you're talking about a timeline of updating binaries on a timeline. So if you notice this has changed, that's now the new picture. Now this is going to have two binaries in the binary relation. It still has the old one, 94387. This is a link to the new one, which has the cat. File name, blah, blah, blah. So the cool thing on this is that, like, I do gardening, and I don't know if you've ever seen like these nature shows where they take a time lapse of a plant and how it moves to the sun or moves, especially vining plants, and but you can see them over a different time scale. Well, here's the same thing where I want to be able to have timelines of different pieces of the garden to where you can see individual time lapses. So we take that picture, take the same before and after picture, it does the crunching on it. Which takes longer with the phone. I'm just doing it, just with the built-in stuff. It's not super optimized. So there's before, there's the after. Now, this kind of thing, you could take this and update it over a longer period of time. Or if you already have a time-lapsed set of pictures, you could ingest that into a timeline. Not right now with the prototype, but that's the point. So if you think of what Git has enabled for text, right? So Git, it's a decentralized, distributed protocol, very, very good protocol for sharing text, very optimized for only showing the diffs or only storing the diffs and being good for storage. But it gives people primitives to work with timelines. You can branch, you can fork, you can merge. These are the same kinds of things. In fact, if we look over here, ibgib does not have diffs in text. ibgib has diffs in the form of DNA. So if you're aware of event sourcing, DNA is like the events that hydrate in aggregate. Well, in our case, we call them transforms. So these are transforms that are applied. So this took a primitive and it applied that fork. So if we duplicate over here, in this prototype, I don't have it to where you can just click on and navigate to the transforms. But so that fork, guess what? It's an ibgib. It's already in this same data structure. So when you go to send data to someone else, you not only can send the data, but you can send the audit trail of the transforms. So in event sourcing, you use events to rehydrate because their whole goal is to get to the same thing. But in ibgib, we use transforms and DNA to get new things. So we could reuse this fork just like applying a git diff on a different branch. In fact, that's how I do it. That's how I have a synchronization space that we won't get to in this video, but it looks at a different space, it looks at the diffs, and it actually reapplies these same this same data. So if you notice, it says this is a fork. It gives a destination, the ib of what it's going to be. It wants to add on whatever at the time. It'll add on a UID and a timestamp. That's to make it unique. It wants to track the DNA, so it has an audit trail. It has an in counter for ease of convenience. of knowing what number in the timeline it is. Although when you have multiple timelines in multiple spaces, it gets funny. You can have parallel timelines and all sorts of fun stuff. And it has the type, which is a fork. The ancestor is a basic fork gib. That's kind of like having a type, hard types that other protocols hard code. They hard code primitives like it's a number or it's an integer or a float or whatever. But the more you hard code, the less you can have meta. That makes it things more difficult down the road. So you can still have typing here. In fact, you can have multiple inheritance typing. Okay. But those diffs, those transforms, these are the same things. This DNA, if you take the parents, from the original fork, if you navigate through the DAG, you can reapply these transforms, and well, the UID won't be the same, but or the timestamp, but you can rehydrate on a different timeline, just like merging in Git. So here it's still chugging on the base 64. There we go. It updated just like our little kitty updated. Click on it. Let's look at her again. Whew. She's crazy cat. Very good kitty. Okay, so there's silly me. Here's when we blow it away, bring it back up, navigate to it again. This is just like saying, we'll go to our test comment. Green thing says it has children inside of it. We go to it. Now again, if you notice, it started off as a different picture, then updated to this picture. We can have it to where it it goes and applies, it mutates this ibgib. It'll to change this relationship, this pick, to the later one, and then you won't have that. But for right now, that's what we have. You go to it, and it always will update it on the fly. It's always about trade-offs. There's the update. There's the slow update there. And there we go. So again, pictures inside pictures, for one thing. So instead of having an Instagram where you have to create a gallery or whatever, you just take the picture, right? You just, I take a picture, and then you can go inside the picture and take other pictures. And so that picture ends up being your name. If you want to add a name, you should be able to go inside the picture, add a comment or a particular type of comment, which will act as the name. But anyway, that sort of thing can happen after the fact. The main point is pictures inside pictures. And the other point is timelines. Parallel timelines for all of your data and your metadata. It comes out to where you still can have localized nodes work with hyper-optimized Databases, I'm not saying this has to be all of your data, but just, derivative data that you want to be able to, that the user has control of, and that can send to multiple apps. That data, now instead of you having your just one little silo, now, this is, it's beautiful for an MVP, but this is not what you want to be your one app to rule them all. You want to be able to take this data, take this DAG, and some other app would be able to interact with this same data, or a split of the data, or a slice or projection of the data. So that's why pictures in pictures, but timelines, and timelines in spaces. So if you lock down just this one paradigm of, who has the ability to project from this timeline, who has the ability to add to this timeline, add what particular types of things to this timeline. So if you lock down that one paradigm, now you can take care of authentication, a smaller surface area for attack surface area, and easier collaboration with projects. There's no I didn't make a whole special class just for this title here, this a comment. It's slightly specialized for the with some basic metadata, but it's not a whole new class. It's still the thing. It's just the, in this case, comment. And so what that gives you is portability, timelines across multiple spaces. And it just makes collaboration easier. So instead of having like a Slack channel where you have to give it a name, or go to a forum and have a new thread, this could be my, if I'm on this, I can be inside of this, and then now I can just publish or tag it and publish it to some other space that acts like the forum, and then you have people that look, and they can understand more context of whatever your question is. So maybe I had a bug on here, and I want to know, what the hell is this kind of bug? Is it gonna kill my plant, or what is this fungus? Is this fungus normal? So you don't just go to a forum and try to describe it. You don't go to a forum and then maybe have all this architecture for authentication in the forum. Maybe that forum's you have to get more reputation at that forum, or who knows what. You send them a slice of your data, and you already have your authentication, which is in the same data, and you can send projections of these to different spaces. So it's a different way of looking at dynamic data. The existing Web3 protocols are still thinking of paradigm and using paradigms inside of files and folders and centralized data. This is not just decentralized. In fact, that's one of the points, another point that I want to make. I'm not fighting against the man here. I'm not fighting against the evil cloud providers or anything like that. I'm just providing a way for sharing mobile data, projections of data, where people have more control over their own data. So in like this case, all this app, all the data is local on my machine. This is not like hosted on a server. Only the app is hosted on the server. All of the data is local, and then you can project to other spaces. Anyway, there's a lot to it. Okay, so timelines, pictures in pictures. Who knows? Who knows what else? Thanks for watching. Have a good one.